So in this video, we're going to be talking about solving triangles. Now you might be thinking like, wait a minute, we've been talking about unit circles, we've been talking about angles. How in the world does this relate to triangles? Well, turns out when you make an angle on a coordinate system like this, if you were to kind of draw it down and create, a line here, you make a right triangle. And so that's kind of where we want to get into, is that how these angles and unit circles, how do they all play together? And we're going to see that today. So in this problem here, as you can see, there's an angle, and it says that this point right here is at 4, 3. And so we know that that's a coordinate system, an x and a y value. And it says to determine the exact value of the 6 trigonometric functions given that angle. And we can see that that angle is pivoting or referencing right there. And so if we want the 6 trigonometric functions, that is going to be sine, cosine, and tangent are the first 3. And then we have the reciprocals, cosecant, secant, and tangent. So I always write it in this order because that way I can see that each ones are reciprocal to each other. And then we go into, well, what exactly does sine, cosine, and tangent represent? And if you need SOHCAHTOA to help you remember, absolutely use that. So SOHCAHTOA, if we remember, is representing sine opposite over hypotenuse. So this one's opposite over hypotenuse. Cosine is ca, or adjacent over hypotenuse. Tangent is opposite over adjacent. Oops, I think I wrote that backwards. My bad. Opposite over adjacent. And then the reciprocals. So for cosecant, that's the reciprocal of sine. So that's going to be hypotenuse over opposite. And secant is the opposite of, or the reciprocal of cosine. So hypotenuse over adjacent. And last but not least, tangent is, oops, I meant to write cotangent. My bad. So cotangent is going to be adjacent over hypotenuse. All right, so we are ready to find our trig function. So in order to figure out what is our trig ratios, we have to go back to our triangle and know which one is the opposite side, the adjacent side, and the hypotenuse. Now the nice part is that because they gave us a coordinate, well, this x here tells us how far it went out, or the adjacent side of this triangle. And so it went out 4 units. So I know my x is 4. And I know my y is 3 because this coordinate is 3 units up, which tells me that this side here for the triangle is 3 for the opposite side. Now for the hypotenuse, they don't tell me. So unfortunately, I do need to find out what is the hypotenuse side, which I'll call C if I'm referring to, the Pythagorean theorem, a squared plus b squared equals c squared. And so I know what these two sides, the legs A and B. So in this case, one of the legs is 4. So 4 squared, plug that in. My B here is the other leg. So that's going to be 3 squared. And so if I square these numbers, I get 16 plus 3 squared, which is 9. 16 plus 9 is 25. And if I have, a square, I have to take a square root of it in order to cancel out that square. So C is the square root of 25, which is 5. Now we always want to use the positive root because we're dealing with length. And length, in this case, on a coordinate system, for a hypotenuse, we are always going to consider it positive. So this is, the hypotenuse here is 5. So now that I have all the sides of the triangle, this makes it super easy to go ahead and figure out the ratio. So sine is just opposite over hypotenuse, so 3 over 5. So then the cosecant must be flipped, so this is going to be 5 over 3. Cosine is going to be representing the adjacent, so 4 over the hypotenuse, which is 5. So 4 over 5. And then the secant is going to be flipped, so 5 over 4. And then tangent is going to be opposite, so 3 adjacent 4. So 3 over 4, and then cotangent is flipped, so 4 over 3. And there we have our 6 trig ratios. And so that's how we can take a coordinate. If we're given a coordinate, we can form that into a triangle. Basically, just plot your coordinate like that and make a triangle, or shoot out, make a line that connects the origin to the point, and you should be able to make a triangle. All right, so let's get into what we're going to learn in this section here. So trig functions on a coordinate system. When we're on a coordinate system, we always have x's and y's, because a coordinate, if you were to plot any point or coordinate on a graph, you have some x and y values to deal with. And the nice part, like I was saying before, is if you plot them, so let's say I plotted in the first quadrant your x and y, you can make a line that connects from the origin to that point, and that allows you to make a triangle. Right? And then that way your x value, that is your coordinate, tells you how far you extend out on the x-axis. So that can help you figure out what your x value is, and the y value, or the y part of the coordinate, tells you how far you extend upwards or down sometimes, but basically how much do you extend vertically on the y-axis. And then this piece right here, we actually call that the radius. And so this r here, to figure out the radius, you can take the square root of it, x squared plus y squared. Or I personally like to use this formula more whenever I'm dealing with figuring out, solving for the radius y or x. Personally, I like to use this one more. X squared plus y squared equals r squared. So this here might look very familiar because it looks like a Pythagorean theorem, and it is. Essentially what it's saying is if you take the two legs, you square them, it should be equal to the radius squared. And so this is essentially me using different variables to represent the Pythagorean theorem, because now we're on a coordinate system, so we need to consider the x, the y, and the radius. Now, I also want to mention here that the radius is never 0, and that should make sense. If the radius was 0, that means that this the triangle, or basically the hypotenuse, the triangle, or the radius wouldn't be extending out, because there would be no radius at all. So that's why we always consider r not to be 0. Another thing I want to mention is that the radius is always positive. Always positive. And this is really important. So when it comes to the radius, we always consider that positive, because it is showing like the length, a size. And so that's always going to be positive. But that's not always the case for x's and y. And the reason why is because of a coordinate system. When we're looking at the first quadrant, all the x's and y's are positive, but the second quadrant, not necessarily true. The x's are negative on this side, but the y's are positive. So depending on the quadrants will depend on whether x and y is positive or not. But the r, or the radius, will always be positive, and I'll practice that with you guys in this video. Now, for sine, cosine, and tangent, if we want to write it in terms of x, y, and r, sine here, oops, that's the wrong pen. Sine here is always going to be opposite, so y over the hypotenuse, which is now r. So y over r, whereas cosine, it will be x over r, because x here is the adjacent side, so the adjacent over the hypotenuse. And tangent will be y over x, like we have talked about before. Cotangent will be x over y, because it is reciprocal of tangent. And then the rest are reciprocal, so we'll have cosecant be r over y, and secant is r over x. So all we're doing here is rearranging our trig function ratios in terms of x, y, and r. Okay, so let's practice this idea using a coordinate point that we're given. So here we're given a coordinate point, and they tell us that we have a point, so an x and y value, that's -2 and 6. And it is the terminal side of the angle in standard position. Determine the exact value of the 6 trigonometric functions of the angles. So at this point, I'm thinking in my head, okay, I have a coordinate. First thing I'm going to do is draw what the picture looks like. So if I have a coordinate here, I have a point at -2, 6. That tells me I'm in the second quadrant. So the second quadrant is where x's are negative and the y's are positive, which is the case that I have because I have -2. I'll say -2 and 6 here. And that's always coming off of the origin is where I want to kind of help myself shape this triangle. So I have that coordinate point and I've connected it with the origin. And when I form the triangle, you always want to draw it down to the x-axis. That is so important that we understand that. You are always drawing the triangle towards the x-axis or down towards the x-axis. So if this is my angle, I have my right triangle now. And so now I need to assign the legs using the coordinates. So like I said before, the x here is going to be the adjacent side because it sits on the x-axis. So that should make sense that it would be the x value. And the y will be the opposite side of the triangle since it is the vertical shift here. So this is 6. And so notice that the x value is negative, which makes sense because you are on the negative side of the x-axis. And the y is positive because you are in the positive direction for the y, whereas down here would have been a negative value for y. Now, for the radius is what we're missing. So we need that part of the triangle because that helps us get all the 6 trig values. So we are going to start by getting the radius by using that Pythagorean theorem, x squared plus y squared equals r squared. So I can plug in my x, which is -2, and I can plug in my y, which is 6, and solve. And so if I'm solving this out, get +4, 36 equals r squared. This would be, oops, I'm getting ahead of myself, 40 r squared, but I have to take a square root to get rid of the squares. So r is equal to the square root of 40. Although I noticed that this is a 40 and I can break down 40. So oftentimes when you're taking a square root, you do want to try to simplify it if you notice you can. So what I mean by that is break it down, see if you can find any pairs. So 40 can break up into 4 and 10. 10 breaks down into prime numbers. 5 and 2 are both prime numbers and they can't break down any further. But 4 can break down into 2 and 2, and that's when you get a pair. So whenever you have pairs, they come out of the root. But anything that's not a pair, like this 5 and 2 that are prime numbers, so you look for your prime numbers. In this case, 5 and 2 don't break down, so that's considered a prime number. And if they're not any pairs, then what you can do is just multiply them and put them back in the root. So 5 times 2 is 10. Notice that I didn't use the 4 because I already broke that down and I already broke down 10, so you don't want to put those back in the root. You only want to put prime numbers back into the root or leftover prime numbers. And so my r is 2 root 10, 2 root 10. And from this on out, I have all 3 sides of the triangle. Now I can easily find the trig, the 6 trig function. So let's go ahead and get that started here. So I have to find sine, which is y over r, cosine, which is x over r, and tangent, which is y over x. And I'll write the other 6 later, but let's first find these 3 here. So for sine here, I have, let's see. So for sine, I have y. Our y here is 6. So I'm going to put 6 on top, and my r here, my radius, is going to be 2 root 10. 2 root 10. So when I'm solving this out, I'm like, oh, okay, I noticed that 6 and 2's cancel. They both are divisible by 2, so this would end up being a 1, and this would be a 3. So then I would have 3 root 10, but I can't have a root in the bottom. That's where I have to multiply the top and bottom by root 10. So I'll go ahead and do that. And so this gives me 3 root 10 over 10, since the two roots of 10s will cancel out the root, leaving me with just 10. And then I can't simplify any further because 3 and 10 don't have any numbers in common. So this would be my final answer for sine. For cosine, I think I have to do something very similar. My x here is -2, and my radius is 2 root 10 again. And so it looks like the 2's cancel, and I have -1 over root 10. Since I canceled out that 2, all I'm left with is a 1, technically, but a -1 since there was a negative sign in front. And then I have to multiply top and bottom by root 10 to rationalize the denominator. So this would end up being a 10 on the bottom and negative root 10 on top. And then this part here, we have tangent y over x, so that would be my y, 6, over -2, my x. But if I divide, that would just give me -3. 6 divided by -2 is -3. And there we go. All right, so now we're ready to find our reciprocal. So we have cosecant, which is going to be r over y. We have secant, which is going to be r, over x. And then cotangent, which is x over y. So for our cosecant, did I write an S? That meant to be a C. So for cosecant here, we have our radius over our y. So some people will just take this answer and they'll go ahead and flip it. Personally, I'll just go back to the original setup. So my y here was 6, so that goes in my denominator. Essentially, I'll take this and flip it. And so 2 root 10 goes on top. Notice if I compared these two, I took the original setup for sine and I flipped it for cosecant. And then from there, I'll try to simplify it. Like 2 and 6, those can cancel out. The nice part with this one for cosecant is I don't have to worry about the root being in the denominator. And so I would have 1 times root 10, which is just root 10 on the top. And then the bottom, I just have a 3. So I can leave my answer like this because there's nothing more I can simplify on the top and bottom, since that's a root and this is a number. So you can't simplify that because they're not like terms. Then this one here is a radius, and this is an x. So I go back to my cosine, since secant is a reciprocal of cosine. And so that would be having the 2 root 10 on top and then the -2 on bottom. And so the 2's cancel out, which is nice. So I'm left with 10, root 10, and then a -1 on the bottom. But if I have a -1 on the bottom and I divide, that's just negative root 10. 1 divided by anything is just itself. So root 10, but it's a -1, so this is going to be a negative root 10. And then this next one here, I have a cotangent, so I'm just going to take tangent's value and flip it. So that's just going to be -2 over 6, which reduces down to -1 over 3, since both numbers can be divisible by 2. So 2 divides into 2 one time, 2 divides into 6 3 times. And then I can't reduce any further. So this here is all my 3 6 trig values. So that one was a little bit lengthy because you have to find all 6. And in the next example too, you will have to find all 6. And you're given a constraint to make it a little bit more specific on what you're trying to find. All right, that's it for this video. In the next video, I'll explain how to do example 2. So check out for that video if you need more direction.